Hi. Before I tell you what the transistor actually is in proper English, let me tell you what the internet thinks a transistor is. This is one of the most fundamentally frustrating explanations that I've ever seen, whether it's from a basic electronics book, whether it's from a textbook, whether it's from the internet, whatever it is. Every time somebody explains to me what a transistor is, they explain it in this asinine, ridiculous, confusing way. Let me tell you what the internet thinks a transistor is. A metal oxide semiconductor field effect transistor is based on the modulation of charge concentration by a MOS capacitance between a body electrode and a gate electrode located above the body and insulated from all of the device regions by a gate dielectric layer, which in the case of a MOSFET is an oxide, such as silicon dioxide. If dielectrics other than an oxide, such as silicon dioxide, often referred to as oxide, are employed, the device may be referred to as a metal insulator semiconductor FET, like a MOSFET. Compared to the MOS capacitor, the MOSFET includes two additional terminals, source and drain, each connected to individually highly doped regions that are separated by the body region. These regions can be either P or N type, but they must both be of the same type and of opposite types of the body region. The source and drain, unlike the body, are highly doped as signified by a plus sign after the type of doping. If the MOSFET is an N channel or N MOSFET, then the source and drain are N plus regions and the body is a P region. If the MOSFET is a P channel or a P MOSFET, then the source and the drain are P plus regions and the body is an N region. The source is so named because it is the source of the charge carriers, electrons for N channel, holes for P channel, F flow through the channel. Similarly, the drain is where the charge carriers leave the channel. What the fuck is this supposed to mean? Do you have any idea what a transistor is? You could read this 50 billion times and still have no clue what a transistor is and no idea what it does and no clue what its practical application is in a circuit. I am sick and tired of college courses where they wait 6 to 8 months to tell you that a transistor is a resistor. Let's open a schematic so I can say that again. A transistor is a resistor. A transistor is a resistor. You remember how I said the resistor gives you the same amount of voltage on the other side, just lower current? It just lowers and limits the amperage that can go through it. That's a transistor. It does the same fucking thing. And for some reason, every single explanation I've ever seen of a transistor over all these years has explained it in this disgusting, asinine manner. Do the people who were explaining things this way even remember what it was like to be learning this? Again, I'm making fun of one explanation on the internet. And I'm sure that I probably didn't pick the best one, but there are millions upon millions upon millions of people who will happily explain to you what a transistor does in the most confusing, ridiculous way. They'll say it's an amplifier. They'll say it's a switch. They'll say that it's a dielectric. They'll say that it's a silicone germanium mixed thingy that passes electricity through diodes and all sorts of confusing shit, but they never ever stop to tell you a transistor is a resistor. Repeat with me. A transistor is a resistor. That's what a transistor is. Let me show you on the schematic here a little idea of what I'm talking about, what I mean when I tell you that a transistor is just a resistor. So the way this works over here, pin 4 is the source, pins 1, 2, 5, and 6 are the drain, and pin 3 is the gate. So the source to the drain is the resistor. So from here to here, along here, this is a resistor, right? Now you may be wondering, it doesn't say what the resistance of the resistor is. So over here, this resistor is 0 ohms. Over here, that resistor is 10 kilo ohms. Over here, that resistor is 33 ohms. But what is the resistance of this resistor? Well, the resistance of this resistor between the source and the drain is set by the gate. So the voltage on the gate is going to be what adjusts the resistance. So think of this like a resistor whose resistance you can actually vary. So you know how they have those dimmable incandescent lamps where you can have low, medium, bright, and off? It's the same idea here. So you can choose. It's not just one resistor. You're not stuck with a resistor where the value of the resistor is constant. Think of it like a resistor whose value you can actually change based on a signal that you send it. So the signal that you send to the transistor's gate is going to affect the resistance of this resistor. Now, for the most part, when it comes to laptop circuitry or any of the circuitry I'm showing here, it's pretty much being used as either infinite resistance or 0 ohms. Infinite resistance or 0 ohms. So the transistor is pretty much being used where it's either a wire or it doesn't exist. It's like it's blocking all power going through. It's pretty much being used as a switch. But the way this works, it's used as a variable resistor. It's used as a resistor whose value can change based on the signal that you send to the gate. That's it. No substrate, no holes, no silicone, none of this dioxide silicone bullshit. No, it's a resistor. That's what a transistor is. A transistor is a resistor whose value you can change. Why the fuck don't they just put that in the first paragraph of every single electronics textbook on earth? I don't know. I would, because I want people to actually understand things without having to take 8 months of coursework and fail based on confusion. But that's the way the world is based. They want you to be confused and not understand how things work because that's our education system. But back to this. A transistor is simply a resistor whose value you can change. And when it comes to laptop and cell phone motherboard, or when it comes to the specifics of what I'm talking about in this channel, most of the time it's not a resistor where you can choose 0 ohms, 5 ohms, 30 ohms, 1,000 ohms. It's either infinite resistance, where it's like it's closed, or it is open and you have no resistance, so it's like a wire. That's pretty much the way this works. So you can use transistors to do a lot of cool things in a circuit. For example, over here, do we want power to go through to the backlight? Well, I don't know. Do we have LCD backlight enable coming in? If LCD backlight enable is present over here, then let's turn this on. Otherwise, let's send this to ground. Now, there are different types of MOSFET. Now, you can do many different cool things with transistors in a circuit. For example, I don't want my backlight to be on when my computer's closed. I don't want my backlight to be on if it's been idling on a desk for 5 or 10 minutes because the battery will die. I want to be able to tell it to turn the backlight on or off. I'd like to be able to have that type of switch. I don't want it to simply just have the backlight be on anytime there's power flowing to the computer. And this is one of the ways that we do it. Now, there are 2 different types of MOSFETs. There's a P-type and an N-type. And again, let's forget about that whole holes versus electron flow versus silicon dioxide crap for a second, and let's just explain this the way it actually is. And this is going to seem silly because it really is this simple. This is a P-channel MOSFET. What that means is that when there is no voltage on the gate, so when the voltage on the gate is lower than the voltage on the source and the drain, that it's going to allow the source to flow to the drain. So the backlight 12 volts, the input voltage on here, so this input 12 volts over here is going to be allowed to flow into the backlight circuit when there is no voltage on the gate. So the way this works is when this other MOSFET over here sees that there is voltage on the gate, it's going to short this to ground, which will lower the voltage over here to the point where it'll send power through. So once LCD backlight enable over here, the signal comes through. What it's going to do is it's going to take the signal that is on the gate of this transistor. It's going to send it to ground, and since the voltage on the gate is going to be lower than the 12 volts over here, that is going to allow the power to flow through the system. Now, if there is no LCD backlight enable over here, it's not going to send that to ground, and this over here is just going to send 12 volts to the input of this transistor, to the gate of this transistor, and since that 12 volts is going to the gate of this transistor, the P-channel MOSFET, which does not open if it sees equal voltage at the transistor as it does in the source of the drain, is simply going to not send backlight power through to the computer. So just to dumb this down to caveman level here, transistor, resistor, over here, resistor. When you have no voltage over here, you have 0 ohm resistor. When you have voltage over here, you have infinite ohm resistor. So when voltage is over here, you don't get a backlight. Backlight power not let through. But when you have no voltage over here, backlight power does get through when you have a shiny screen. It's that simple. So this is another way that we can manipulate electricity to do what we want. So a transistor is a resistor whose resistance is based on an input signal. We can use this to do a lot of cool things. So over here, again, we're using it as a switch. It's not a variable resistor. It's either a resistor who has infinite resistance or a resistor that has no resistance, aka a flat wire. And that's how we're able to use this to get what we want. Now, some of the things that I want you to think about here are being able to read the schematics and read the circuits to know what they're supposed to do. Over here, it says that this is a P-channel MOSFET, right? So if you see that there's 12 volts on the input of this transistor over here, and there's 0 volts on output, now you want this thing to be opening, what you should be thinking to yourself is, this is a P-channel MOSFET. So if I see 12 volts here and 0 volts on input, but I don't see output, that must mean that either something is wrong after the circuit or the transistor is bad, because with my new learned knowledge, I know that a P-channel MOSFET should allow the signal to go through when there is a lower voltage on the gate than there is on the source. And that's something that you should be thinking about. Now, if you have that knowledge and you see that there's 0 volts on the gate and that the power is moving through it, you should be able to say, okay, that's working the way it's supposed to. So being able to tell a P-channel MOSFET from an N-channel MOSFET, knowing what these two things are, and also knowing how to use Google in your brain to look this up is also going to be very helpful. So you can simply take that number over here, that FDC638APZ, you can Google it, and you can figure out from the company's data sheet if that's a P-channel or an N-channel MOSFET. Technically, you should be able to tell if it's a P or an N-channel MOSFET just from looking at the little internal picture in the diagram. My memory is not that good. This is one of those embarrassing things, by the way, which you're all going to laugh at. If you know me in person, you know that I've probably gotten your name wrong, even if we know each other for a long time. You know that if I put this mouse down over here and forget about it, that in 5 seconds I will have no idea where it is, even if I'm looking at it. And that even after I've known what a transistor does for 10 years, and I still can't remember the little picture. Again, you can laugh. It's a very simple little picture. I should have been able to remember it. I can't. I Google it every single time. And sometimes I even forget the difference between the P-type and the N-type. It's just, my memory for that type of stuff is just complete and utter garbage. So that's that. So even if you don't have a memory like I do, even if you do have a memory like mine, you can just Google and figure that out. Now, on to some practical applications of a transistor. So again, over here it's being used as a switch. So the way this system works is you have a voltage divider here, which is taking the 12 volts and it's making it into a smaller voltage. But it's not actually going to work as a voltage divider unless the bottom of it gets to attach to ground. Now, what's going on in this circuit is that you have voltage going to the gate, and that voltage is going to be 12 volts. Now, that's not going to allow the P-channel MOSFET to open, and therefore this 12-volt system rail is not going to be sent to the backlight rail over here, and this is never going to turn on, and you're never going to have a light in the screen. However, if the LCD backlight enable signal to this transistor goes through, this is an N-channel MOSFET. The way this works is when it sees power, it opens and allows power to go through. So once this opens, it's going to allow this power to go through over here, and you're going to have this going to ground. So when that 3 volts shows up over here, that 3 volts is going to cause this to turn into a wire, which is going to send this to ground, which is going to activate this voltage divider. Remember, a voltage divider needs to go to ground in order to actually work. So what's going to happen here is that you're probably going to get something lower, like 3 volts or 5 volts or 2 volts on the gate of this transistor. And since the gate of this P-channel MOSFET is going to be lower than the source, that's going to tell the transistor, hey, open, let power through. The gate is only 2 or 3 or 5 volts, whereas the source is 12. That means we can open and come out the other side. So that resistor is going to be turned into a 0 ohm resistor, and that's going to allow the power to go through. That's how you can tell the machine to start enabling the backlight circuit. There are other interesting uses of a transistor as well. So what I mentioned in the inductor video before was how there was a buck converter that was being used for CPU power. So what I was showing you is how you can turn a bunch of pulses into smooth power by using an inductor and a capacitor. So the inductor is only going to pass the DC, and the capacitor, which is going to ground, is only going to pass the AC, and it's also going to retain some charge. And the way that works is that you're going to take a bunch of pulses and you're going to turn those pulses into of 12 volts into a smooth 1 volt. So even though those pulses of 12 volts average out to 1 volt, the CPU doesn't want to see 12 volts now and 0 volts, 12 volts now and 0 volts later. The CPU wants to see a constant 1 volt, or else it's not going to actually do anything and your computer's not going to work. So I showed you how the inductor and the capacitor even it out. What I'm going to do now, if this ever finds the fucking circuit, here we go, is I want to show you how this can be used for a buck converter. So what I was showing you over here is how on this side of the transistor you had this side of the inductor you had a lot of pulses, a lot of spikes, whereas on the other side of it where you have the capacitor and the inductor, it was smooth. Now the way this works over here, how do you get those spikes? How do you actually get the spikes to happen? The way you get the spikes to happen is very simple. So over here you're going to have the 12 volt rail of the computer. Up here you have a 12 volt rail, and that's going into I believe, the source of this dual MOSFET. There's I think this is like 2 MOSFETs in one package. So that's going to be going over here. Now, what that's going to be doing is that is going to be opening based on the signal at the gate over here. And on the other side, you have a MOSFET over here that's sending that same power to ground. So it's pretty much giving it a path of where to go. So you have that 12 volts, and what it's doing is it's opening and closing it. So that gate and that gate signal are going to open it and then close it, open it and then close it, open it and then close it. So you have a spike of 12 volts and then 0, a spike of 12 volts and then 0, a spike of 12 volts and then 0. And what that does is it creates a voltage that averages out to 1 volt that the inductor and the capacitor can then turn into a flat line. So we can use transistors to turn high power supplies into low power supplies, a higher 12 volt power supply into a lower 1 volt power supply. That's one way that a transistor is very helpful. So by turning into a wire, 0 ohm, but by turning into a wire, then an infinite ohm resistor, wire, infinite ohm resistor, wire, infinite ohm resistor, we get 12 volts, 0, 12 volts, 0. And we have a chip over here that's actually sending that signal to the gate to control all of this. So this over here is a buck converter controller chip. So over here, this is actually sending out the signal to the gate. That's sending out the signal to the different gates over here, and that is what is controlling this MOSFET over here, this dual MOSFET thing in one package, or whatever the hell it is. I don't care. I know what it does, and that's really what's important. So the whole idea here is I want you to be able to see a transistor and have an idea of what it does. I want you to see a transistor and have a practical idea of its usage in a circuit. Don't read that shit where they're telling you, like, again, like they're telling you about the silicon dioxide and the holes and the P channel and the substrate. That is all a bunch of confusing malarkey, and I don't want anything to do with those types of explanations. A transistor is a resistor whose resistance value will change based on a signal that you send to the gate. You have two different types of transistors, two main types that I want you to be thinking about. You have transistors where when there is voltage on the gate, it will open and allow power through, and then you have transistors when there is no voltage on the gate, will open and allow power through. And in order to properly troubleshoot the circuit, you need to understand what type of transistor that is. Is it an N-channel transistor that is going to let power through when it sees power on the gate, or is it a P-channel transistor which is going to let power through when it doesn't see power on the gate? You also have different types of transistors, which I want to show you, which are bipolar junction transistors. So let me show you a bipolar junction transistor. This is it's pretty much the same concept, but they just use different letters and wording and everything. So here, you don't have a gate, a source, and a drain. You have a base and a collector and an emitter. But I want you to understand that it's pretty much the same thing. So let me just find that and zoom in so that I can show it to you on the screen. So, okay, here we go. So this is a bipolar junction transistor. So over here, you have the base. Again, the same concept. So the C to E, the collector to the emitter. The collector to the emitter, this here is the resistor, right? And this resistor's resistance is going to vary based on the signal of the base. So base, same as gate. Collector, same as source. Emitter, same as drain. I may have mixed up collector, emitter to source and drain, but whatever, you get the idea here. And that is pretty much that. A transistor is a resistor whose resistance changes based on the input signal. That is what a transistor is. It is not, again, take that other definition and just delete it, erase it from your mind. If you want to become an engineer, if you want to create transistors, if you want to, again, anything like that, by all means, read all about the substrate and the silicon and the holes and the P channel and the N channel. Read about all that to your heart's content. If you want to understand how to practically repair circuits from having no knowledge, a transistor is a resistor that you control based on an input signal. We can use it to turn circuits on and off. We can use it to take a standard steady power and cut it up into little pulses of power, so that if you have this much and you need this much, you can take this and you can turn it into that. That's one of the great uses of a transistor. And we can also use it for amplifiers. I'm going to explain that, even though that has virtually nothing to do with how laptop motherboard repair works, because that was my start into electronics repair professionally, was repairing amplifiers and repairing audio gear. I'm going to discuss how that works, but first that requires that I explain to you what a voltage divider is. I feel a little guilty that in this video, while explaining what a transistor is, I talked about a voltage divider without telling you what a voltage divider is, but I'm going to be getting into that in the next video. So a transistor is a resistor whose resistance varies based on an input signal. That is it. It's a resistor. It's just a resistor that you can control with a signal that you put into it. That's all.